Hi, this is Reid Spears presenting my supercarbon project on esters. The reason why carbon has so many new compounds every single year is because carbon has half-filled shell and can form many types of compounds. Carbon is a common molecule on Earth and can be found in many compounds. The molecules carbon bonds with, like oxygen and hydrogen, are also very common. Life is based on carbon, so billions of life processes revolve and interact with carbon, and the compounds are not so tightly bound that they can readily be involved in further reactions. The definition of an ester is an organic compound made by replacing the hydrogen of an acid by an alkyl or other organic group. Many naturally occurring fats and essential oils are esters of fatty acids. The history of esters, specifically methylformate. Methylformate is the simplest ester and the condensation product of methanol and formic acid. Brown in 1975 was the first to detect methylformate, and it is credited for discovering it. It was found when several emission lines that were assigned to rotationally distorted methane were correctly assigned to methylformate, which made apparent the existence of methylformate. The process of how methylformate is made. Methylformate can be produced in a lab and can be made with the condensation reaction of methanol and formic acid. The products of this reaction are the methylformate and water. However, for industrial use, methylformate is formed when you combine methanol and carbon monoxide with the pressure of a strong base such as sodium monoxide. This process gives a 96% yield towards the methylformate, but it may suffer from its sensitivity to water that is often present in carbon monoxide. To avoid this from happening, most manufacturers will use very dry carbon monoxide. Methylformate has several physical properties, such as a density of 0.974 grams per milliliter at 20 degrees Celsius, its water solubility is 300 grams per liter, its melting point is negative 100 degrees Celsius, its boiling point is 31.7 degrees Celsius, and its molecular weight is 60.1. Methylformate also has several chemical properties, like it is extremely flammable, readily forms explosive mixtures with air, incompatible with oxidizing agents. Its extinguishants are alcohol foam, carbon dioxide, or dry chemical, and its flash point is negative 18.9 degrees Celsius. Nomenclature. Esters names are derived from the parent alcohol and the parent acid, where the latter may be an organic or inorganic acid. Most simple esters for carboxylic acids are named depending on the more traditional names like formate, propionate, acetate, and butyriate, unlike the IUPAC nomenclature methanoate, ethanoate, propanoate, and butanoate. However, esters from complex carboxylic acids are more frequently named using the IUPAC system that is based on the name for the acid, followed by the suffix -ate. Here are 5 examples of naming esters. The first example is ethyl ethanoate. You get the ethanoate from the ethanoic acid present in the formula, which is blue, and the ethyl is because of the ethyl group on the other end, which is red. Another example is ethyl propanoate. The ethyl comes from the red, and propane comes from the blue. Take out the E in propane and add the -ate, and you get ethyl propanoate. Third is propylmethanoate. You get the propyl, which is the red formula, and the methane, which is blue. Once again, take out the E and add the -ate, and you get the propylmethanoate. Fourth is methylbutanoate. The red is methyl, and the blue is butane, which can be made into butanoate. Lastly, propyl ethanoate is shown where the red is propyl, the blue is ethane, and when the suffix -ate is added, it makes propyl ethanoate. Uses of esters. Esters are found in nature but mostly used for industrial purposes. They have many uses, but there are 3 major ones. The first is as artificial flavoring that are often found in waters, candy, ice cream, and even perfume. The second is when they are used as solvents. These solvents are found in fats, gums, paints, varnishes, cellulose, oils, and other things like this. The last is when it is used as a plasticizer, that is, a substance added to synthetic resin to produce or promote plasticity and flexibility to stop things from being brittle. This image is the MSDS cover page for the ester ethyl propionate. This is a diagram of propyl ethanoate. It has 10 hydrogen, 5 carbon, and 2 oxygen. This is my model of methylformate. It has 2 carbons, 2 oxygens, and 4 hydrogens. Now we'll go through the last 10 slides. This is alcohol. The definition is the hydroxyl functional group with bond angle. In chemistry, an alcohol is an organic compound in which a hydroxyl functional group is bound to a carbon atom. The model is of methanol. Alkyl halides. Alkyl halides are a group of chemical compounds derived from alkanes containing one or more halogens. They are a subset of the general class of halocarbons, although the distinction is not often made. This is a primary alkyl halide. Ether. They are a class of organic compounds that contain an ether group, an oxygen atom connected to two alkyl or aryl groups. This is a model of dimethyl ether. Aldehydes, an organic compound containing the group CHO, formed by the oxidation of alcohols. This is a model of formaldehyde. Ketones. A ketone is an organic compound containing a carbonyl group, carbon-oxygen, bonded to two hydrocarbon groups made by oxidizing secondary alcohols. This is a model of acetone. Carboxylic acids. An organic acid containing a carboxyl group. This is a model of formic acid. Esters. An organic compound made by replacing the hydrogen of an acid by an alkyl or other organic group. Many natural occurring fats and essential oils are esters of fatty acids. The model is of ethyl propanoate. Amides, an organic compound containing the group CONH2, related to ammonia by replacing a hydrogen atom by an acyl group. The model is of the primary amide. Lastly, polymers, a substance that has a molecular structure consisting chiefly or entirely of a large number of similar units bonded together like many synthetic organic materials used as plastic and resins. The model is of propylene. Thank you for listening. This was Reid Spears presenting my Supercarbon project.